Hello and welcome to Math Lessons with Linda. Today's topic is geometric sequences, and we have previously talked about arithmetic sequences, so view that one as well if you're in that unit. And today our geometric sequence we are going to discuss is 18, 9, 4.5, ... That means that our sequence continues on in the same pattern, which is what we are going to work on figuring out today. So in an arithmetic sequence, recall that we were adding the same value every time to get to the next term. In a geometric sequence, something different is happening, because to go from 18 to 9 and then 9 to 4.5, it's not the same difference like we had in arithmetic. So in a geometric, we're looking for something called the R, which is our common ratio. And what that means is that each time we go from term to term, we are multiplying by the same value. Now, the way that we figure that out, especially when you look and you see you've got decimals and things like that, what we're going to do is we're going to take the second term and put it over the first term. So like 9 over 18 reduces to a half. And I think, oh yeah, half of 18 is 9. I'm going to do the same thing here. 4.5 over 9. If I reduce that, I also get a half. And I'm like, yeah, 9 times a half is 4.5. So I can tell that each time the next number is half of the previous number. So for this geometric sequence, the R value is a half. So remember that when you are multiplying, sometimes you will be multiplying by a fraction and not an integer value. Okay, there are two different formulas for geometric as well. They are the same as arithmetic. It's recursive, which is the least helpful because for a recursive, remember, we are only finding the terms exactly in order. And the recursive has two parts, just like in arithmetic for the recursive. Our a sub 1 is 18. To get any other term, so like the second term, what I would do is I would take the previous term, right? So if I want to find the second term, 2 minus 1 means, hey, take the first term and then multiply it by my R. So 18 times a half is 9, and then 9 times 4.5. But this is a slow process because if I want to get to the 20th term, I have to find all 20 of those terms. We would rather use the explicit formula, just like we did in arithmetic. So the explicit formula for a geometric looks like this. This is just the general form. It is a sub n equals the first term, so whatever our a sub 1 is, times, and then our R value raised to the n minus 1. So please note that the only thing that is getting this exponent is the R. This a sub 1 gets multiplied after you've done all of this. Follow your order of operations here. So we already have the first three terms in our sequence here. So let's write our formula and then use it to find another term. So for this, our a sub 1 was 18, our R was a half to the n minus 1. So here's our explicit for this particular sequence. And let's not go too far out, let's find our fifth term, right? Now we feel pretty sure that since we have a decimal here, as we keep taking half and half, we're going to still end up with a decimal. And our numbers should be getting smaller. So when I get to a to the fifth, it should be smaller. So I'm going to have 18 times 1/2. And then the fifth term is what I'm looking for. So 5 minus 1 goes here. So when you are using your calculator, you are doing 5 minus 1 to get 4. You are raising 1/2 to the 4th power. Now you can multiply by 18. This is all calculator work. You should get a sub 5 is 1.125, and that makes sense from what we talked about before. You can go back up here and do 4.5, divide that by 2, you'll get the fourth term, and then multiply that by a half again. I should not say divide, I should say multiply by a half, and you will end up with our 1.125. So this is an example of how you can use both the recursive and explicit formulas in a geometric sequence.